functions, which means it will have two independent variables, two inputs, and one output, and for the most part, we will interpret the inputs as x and y, and the output as z. And so the output of your function is going to be graphed vertically in terms of z. But in general, you could have any number of independent or input variables. It's just we run out of options in terms of representing them graphically if we have more than two inputs and one output, because we live in a 3D world. You can interpret 4 dimensions as 3D with motion. That's a way that you can interpret 4 dimensions, but otherwise you have to kind of just imagine what things are like, geometrically, if it's beyond 4D. So I start off pointing out that we're talking about surfaces. We will look at pictures of 3D surfaces, but really your surface could be any dimension, or you have any number of input or independent variables and one output variable. And out in the real world, the variables often mean something, that there's measurements attached to them. And in fact, a lot of models don't even really fit the definition of a function if you worry about every every input has to have only one output. There are plenty of times when you're actually interested in surfaces where you might have more than one output for certain inputs. But anyway, sometimes we'll kind of focus on the traditional definition of a function. So the first example that we have, I have just made it a surface, and we're pretending that it's some terrain, some mountains and valleys. It doesn't really have any meaning aside from that. So, picture this being some sort of terrain. Our measurements are in kilometers, and this is the 3D function that models the surface that we're talking about. So our output z gives the elevation of the terrain. So first, we're just kind of getting used to playing with the functions, and so we want to find the elevation at these various points. So why don't we divvy up that work? We've got 4 different points, so why don't we have table 1 do the first point, and table 2 do the second point, and table 3 do the third point, and I will do the 4th one, okay? So we have 3 tables.
No, ours is pretty easy.
Table 1, you're trying to evaluate when x is 0.
Is it 0?
Yeah, what, I think I've typed the answers in here from a previous time we were doing it, but why don't you figure out if, well, one, double check if these are right, because